So I decided to try something a little bit different for me, because I saw a lot of good speakers doing this. And I posted on Twitter before my talk and solicited some advice about what would you like to hear as far as performance testing. And the first response was, well, let's just show a bunch of emojis, and that's a good plan. Slack has very good emoji support, and so I started working on my slides, and I was making pretty good progress. I'm very proud of this slide. But then, unfortunately, a couple of people replied, and they started asking serious questions, like, have you ever tried model-based testing? The answer to that is no, by the way. And what features are the hardest to test, and what's your current approach to performance testing? And so, Alina, if you're in the audience, I know that you thought it was a good plan to show emojis, but unfortunately, I will have to talk about performance testing today. My personal story or background with performance testing started about 2 years ago when the CEO of our company, Stuart Butterfield, wrote a document, and it included this phrase in it. And all right, you could see it's effective, right? Despite the profanity, or maybe thanks to the profanity, this actually generated a lot of excitement in the company. Usually when the CEO says something like this, people pay attention. And so a bunch of engineers obviously went off, and ran all sorts of profilers and looked at all sorts of graphs and fixed all sorts of bugs. And this is just fine, by the way. This is this ad hoc approach to performance is sometimes necessary. At Slack, I believe I heard the word surge used at some point, and it's totally fine to gather a bunch of engineers and get them excited about something, and we'll just go and fix all of our performance issues. There's absolutely nothing wrong with doing that. But once all the performance issues have been fixed, of course, the issue is that well, most of the code that will be part of your product in maybe like a couple of years hasn't been written yet. And there's a lot of performance issues in those GitHub PRs that haven't been merged yet or even haven't been written yet. And also, the other thing about ad hoc approaches is that performance issues are actually very subtle sometimes. I mean, sometimes you do a code review and you find an obvious issue. But a lot of times it's really not obvious. And this is not something that can be very easily caught by engineers when they're just looking at code. And so that's when I took a step back. I come from a background of test automation, as Max mentioned. And I took a step back and I thought, well, how can we write some kind of a system that will have allow us to have a systematic approach to preventing performance regressions, and also rewarding engineers for doing performance improvements. And so at that time, I'm a visual person, so I thought of kind of two images. Image number one is we want to have some sort of way to just visualize performance over time for some kind of metrics. And then when we see things change, people immediately start asking questions. By the way, there's this, I think, psychological effect that people just love looking at data and visualizations of data, and they just immediately start analyzing it. So, a lot of you are probably doing this right now. And even, if you just have this and people start asking the right questions, that's actually already a very good start to having a sort of a systematic performance approach. We have a guy in our company called Kevin, and Kevin is a big contributor to the develop performance. I don't know why you're laughing, Zach, but he's a big contributor to our develop performance channel, and he just basically asks questions. He looks at graphs, asks questions, and people fix performance bugs. And it's absolutely wonderful. But I thought, what if we had a way to automate Kevin? And so, of course, the second visual that came to my mind is a Slack alert. It has to be a Slack alert, right? By the way, how many of you use Slack here? Whoa, OK. All right. I'll take bug reports outside, in the hall after the talk. And performance alerts are cool because we can actually, do what Kevin does, and we can say, hey, you're about to make something slower or faster. But what's even cooler than, just alerts is pre-merge alerts. The best time to catch an issue is as early in the sort of development lifecycle, as possible. And what if we could actually alert you before you merge your code into master that you're about to make a mistake, or actually that you're about to do something really awesome? So how do we get this done? If I was just to stop a random person on the street and ask them, how would you do performance testing, I'm sure this is what they will tell me, right? You take a value from the developer version, you compare it against the baseline, and then you alert if they're different. Yes, so super easy. At this point, you may be asking yourself, well, what value? Here, as far as values, we're talking mostly about, in Slack's case, and I think in the case of most applications, is execution time of key customer scenarios. So for Slack, it would be like launching the application, switching channels, doing search, those kinds of things where customers expect snappy behavior. But it doesn't have to be just timings. It could be frame metrics. It could be resource usage like memory and CPU utilization. Really, if it can be measured, it can be plotted over time, and we can alert on it. And what about the baseline? Well, the baseline is just the latest value in master if we're going to do pre-merge alerting. So, this is the naive approach. Some of you may be already thinking, well, what is wrong with this approach? And there's a problem, is that our results, unlike in functional testing, my background is in that, and it's super nice in functional testing because you either have a pass or fail. Well, okay, you have flaky tests sometimes. But in performance work, results are variable. And sometimes they're very variable. So when I got started with this, I just wrote an automated test that spit out a bunch of performance metrics. And before I had any sort of backends to analyze the data, I just dumped it into a CSV file, put it into the spreadsheet, and I looked at the picture, and I was very sad. I was just going to give up and go home. But then I talked to some very smart people at Slack who work on data, data scientists. And of course, there's a way around this problem, and that way is statistics. Statistics was not my favorite course in university, but the more I work with data, and we all work with data in this day and age, the more I appreciate it, and I kind of wish that I had been better at it. So for those of you who are still in university, don't skip the statistics class. So what can we do with stats? So what if instead of just collecting one single value, we collect a population of values, a set of values from both the master build and the development version? So what does that give us? Well, the median of that set becomes sort of the point on our trend line. And as you can see, it kind of smoothes things out a little bit. Still variable, but it's better. And then the comparison gives us the trend. Is it getting faster? Is it getting slower? Or is it the same? And the particular statistical test that our data scientist picked, and I had no reason to question his authority, was called the MannWhitney U test. And this test actually, is good at comparing two data sets. And essentially, it does that by looking at the overlap between the data sets, as you can see by the picture on the right. The more overlap, the more likely it is that the data sets are similar. So ultimately, the MannWhitney U test gives us a p-value. And I'm not going to go into the sort of the scientific definition of p-value. But in human terms, if we take the inverse of the p-value, we get confidence. How confident are we that these two sets are actually different? And so the statistical approach, following up on the naive approach, is we collect a set of n values from the dev version. We test the data against the latest set from master. And we alert if the confidence that we got is higher than a certain threshold. And if you kind of are thinking a step ahead here, you'll notice that we control two variables here. We control the n, the number of sort of the size of our set, and we control the threshold. And here's how that kind of translates into real world, sort of like as we were thinking about how to build our system. Higher number of values, generally, this is not very scientific, but it just gives us better statistics. So you'll ask any data scientist, and you give them like 100 data points, and they're like, 100? Can you give me like 1,000,000? Give me something to work with here. But of course, that also comes with a catch here, is that to generate this large data set, sort of in a controlled environment, we need more device time, and we'll get into that a little bit later. We can also play around with a threshold on which we alert. And here, if we sort of say only alert if we're 100% confident statistically that the two sets are different, we get a lower false positive alert rate. However, we also lower the chance of catching valid bugs. Another sort of way to think about it is that we also decrease the window on which we can alert. So like, the percentage in percentage terms of the value. So before we transition into sort of how to build the system, I wanted to take another detour and ask, who are we building this for? As Max mentioned, I work on the developer experience team, and pretty much all the tools that our team builds, the end game is that it will be owned by developers. Developers. Oh, woo, okay. Anyone see that video, by the way? All right. Rebecca here in the audience asked me, please don't play this video on the big IMAX screen. It's really scary to see Steve Ballmer in high resolution or in that large of a size. I worked at Microsoft as my first job out of university, and I actually got to witness some of his antics on stage. He is a very energetic person. I'll just leave it at that. And in order for us to have our sort of tool be used by developers, I mean, we're about to alert developers on whether they did something wrong or not. We need to earn their trust. And trust is kind of a blurry, thing. But in this case, I think I define trust as a function of valid detections over noise. So the more, obviously, the more you can detect, the more trust you earn. But the point about noise, I think, is that noise is actually a bigger deal. I mean, if your system is very quiet, doesn't cause any noise, and it doesn't detect anything, no one really is going to notice. If your system does detect stuff once in a while, but it's also super noisy, people are going to notice, and they're going to hate it. So when we build our system, we have to think about trust and how can we measure that we're actually doing the right thing here. So that kind of sets the stage and the kind of requirements of what we're building. Now let's talk about the how. It all starts, as I said, with a developer. And this developer is merging a change into master. And there's some kind of a source control system. Probably most of you use GitHub for that. And GitHub can be configured to kick off a job in probably continuous integration system of your choice. We use Jenkins. I'm sure many of you also, unfortunately, use Jenkins. Jenkins, it's a love-hate relationship. The performance test job kicks off tests on devices, gathers data, sends it up to a backend, and now this backend has some data store, and we can actually display some kind of a visualization of trends based on the data that we've populated from here. So already, as I said, this is a part of it, and if you only build this, you're going to get some use out of your system. But of course, we want pre-merge alerts, so we have a second developer who is going to open a pull request, not merge, but just open a pull request. GitHub detects that that happened, kicks off the same performance test jobs, runs on that job. But now in the backend, it knows that it's a developer build. And instead of just storing the data, it will actually do the analysis. And if the magic happens correctly, then maybe you'll get a Slack alert. Exciting times. So super easy, right? Now let's look at each one of these building blocks in more detail. And I'll just have to say that due to when I did the dry run for this presentation, I was like 46 minutes. So I had to cut a lot of detail out here. There's definitely a lot to talk about. So I'm just going to try to touch on some of the key findings that I thought were exciting and as we learned about the system as we were building it. So let's start with the performance test job. This not very pretty slide here. We're going to have some kind of a build node that is going to have a device attached to it, and we can run tests on this device, gather data, and send it to the backend. Of course, we want things to go a little bit faster, so we're going to have more than one device. And at this point, as you start working with physical devices, and you will realize that they have tremendous effect on your performance data, you'll realize that you probably want to reboot them between each test run, and you want to clean their state and so forth and so on. And maybe you'll add this layer called the device provider that manages all the physical device stuff. And then you have your runner that kind of utilizes that. And what's the problem with this? Well, I'm sure many of you have some sort of version, maybe at some point in your company, of a physical device lab. And I've used this slide, I've overused the slide, I think, since like 2011. This is the physical device lab that I built for the Google Wallet project. Back in the day, emulators didn't work so well, so we kind of have to rely on that. These physical devices are actually stuck to a whiteboard. It's really cool because you could see all the screens and all the tests are running. It was working really well until the Velcro on the phones melted because of the temperature, and then the device lab collapsed. So I'll just use this as an opportunity to say, don't go there. Like, try not to work with physical devices unless you have the capability in your company to build a data center quality device lab. This is screenshots, I believe, from the Facebook device lab that they talked about in a blog post. And so if you don't have a team that builds data centers, don't use physical device lab. So what can you use instead? Well, it happens that there are many third-party solutions, and they're cloud solutions. The one that we picked is Firebase Test Cloud. We were already using them for functional testing on virtual devices, and so it was very easy for us to build out the infrastructure for that. You're welcome to explore others. There are some that are actually geared towards performance testing, but we decided to go with Firebase. And so the cloud version is great because it takes an entire class of issues, non-performance related issues, out of the equation, like mucking around with physical devices. And it also gives you scalability. Like I can go to, I can dial up the number of attempts super easily. I can run like 100 or 200 tests in parallel. So cloud is great for that. On the other hand, you do lose a little bit of control. I'll tell you a couple stories about loss of control. One is, not so exciting, but essentially we started getting spammed. Our developers started getting spammed with all these false alerts. And just looking at the data, I was like, oh, this doesn't make any sense. All the metrics are changing. And so then I thought it was an environment issue. I reached out to the Firebase test team and asked them if they had upgraded the devices. And sure enough, they just decided to push an upgrade to the pixels that we were using for testing. And our developers got spammed. So we have no control over that other than, well, we can talk to the team and make some feature requests. The other funny story is that recently, the so-called president of the United States decided to test the emergency response system of the United States by essentially spamming every single device in the United States with an alert. And there's no way, no legal way for companies to actually, I believe, device manufacturers or operating system manufacturers to block this alert. So Firebase Test Cloud had a 1.5 hour planned outage where they did not run any tests. So literally Trump brought down our CI system. It was that bad. I was very mad. Okay, so that's all I'll say about the perf test job. Now let's move on to what actually happens on the device. Oh, and by the way, one more thing. Some of you may be wondering, why do you have to use a physical device? Why can't we use an emulator? I'll just, I don't have a lot of time to go into that, but I'll just quickly say that physical devices just behave better in terms of variability than emulators, and they give you actually, well, obviously a more realistic performance profile. So use physical devices. So what happens on the device? You're going to have two things running there. You're going to have your application, and your application has to be somehow instrumented to track certain metrics. You could give a whole talk about how to instrument for performance metrics. I don't have time for that, so I'll just say you could start very simple with just start stop API that captures the timing, saves it off to a hash map, and then your test has access to the entire process, the application sort of class path, and can dump those metrics to a CSV file, and then you can pretty easily grab that from the device after your test. So the instrumented application part is, as I said, non-trivial, but I'm not going to go into it. The instrumentation test, I did want to mention a few things that we learned. There's a lot more to talk about, but it'll just be like 4 things. So first of all, you will want to focus on your client. As our CEO said, our clients must be fast as fuck. It's not like the server can be slow. No, but really, usually the team that works on the clients is a separate team from the backend team. And so, aside from the fact that the network is highly unstable and variable and would be a nightmare for performance data, also backend regressions should not block your client engineers from merging code, which is what we're going for here. And so what that means is that we use record and replay, where we basically capture the network traffic and then replay it during our test, so we completely sort of make that part hermetic, and we take the network out of the equation. We used to use WireMock. It's a good library, it's a good Java library, but it's very, very heavy. So we recently switched to OKReplay, which is an open source library by Airbnb. And that library is built on top of OKHTTP interceptors and Espresso. Both of those were a good fit for us. And essentially, you can have an Espresso test that runs in record mode, saves off what they call a tape, and then you can replay that tape during your replay test. So next thing is you'll want to keep it real. We really want to catch regressions that are actionable and that engineers can actually, that represent the real world usage of our customers. And what that means is that we want to preserve the sort of production object graph as much as we can and run against a realistic release-like configuration. So by the way, this is exactly the opposite of what I recommend doing when you're doing functional testing. When you're doing functional testing, you want to isolate things and sort of like separate out all the layers and test them separately. But in performance testing, I found that you'll get better results if you can preserve as much of your app as you can. So you're interested in the way that components interact with each other, not only like how they interact as a unit. Unfortunately, that means that you're going to have to deal with some large tests, and they're going to be pretty tricky. So this took a lot of time and effort. Which leads into the next point. How do you make this stable? Performance tests will be executed a lot. If you think about functional tests, you only need to execute it once during your CI run. You're done. The number of attempts here can be whatever number, but you're going to execute performance tests a lot. So the stability bar is very high. Even like 99.99% stability is not high enough for performance tests. And I don't really have a lot of advice here other than just try not to compromise on flakiness. You could sort of start building around flaky tests and saying, what if we just run like more attempts and retry tests and do all that kind of stuff. But try really hard to just make it not flaky. I spent a lot of time with an API that I developed called idling resource. It's not a perfect API, but for this use case, it actually works pretty well. So our performance tests utilize this idling resource pretty heavily. And we've managed to get sort of things on Android actually to a very stable point. And finally, when you do make your tests stable, you have to keep it working. And what I mean by this is that breaking your performance tests has to be merge blocking. I've spent like days and days before our tests were merge blocking because I just wasn't confident in their stability, fixing things where a developer merged some change that just broke the test, and it was very hard to figure it out. It was kind of like this image here, and I figure we have about 12 minutes left, so it's time for a little break, and we can just look at this GIF. So definitely, as soon as you can, make it merge blocking. That's going to save you tons and tons of like dev engineering time. So back to our circle of life here. Let's talk about the backend. I'm not a backend developer, so this is going to be very quick. We have a very simple API. We have a create performance build API that basically just does a very quick sanity check and allows the perf job to just fail out quickly if something is wrong. We had some issues with Jenkins and duplicate builds. And then we have a complete build API that takes in the whole perf data set and then does the analysis and potentially alerts you in Slack. Performance data is pretty self-explanatory. We have some metadata about the build at the top that will allow us to actually build the alert to the developer and to allow us to correlate it to a certain code change. And then the metrics, we actually used to send up device information with every single metric, which is why they're sort of not conflated together, but you're going to have obviously a lot more data than this. It depends on your number of attempts and also the number of metrics that you're covering. And also a funny story here is that we had a bug that was kind of breaking our backend for a very long time, and nobody really figured it out until I started looking into it, and it ended up that we were sending out we were running 11 attempts for every single perf build, and we were sending out sort of 11 times 11 number of data that we actually needed. Or like 121 attempts instead of just 11. It ended up being a Python default argument issue. So in Python, if you define a default argument in a constructor of a class, that actually turns into the shared memory object. And we were actually adding metrics to that list. And so every single one of our attempts was growing the data set exponentially. So that was a really fun bug. It was very good to figure out and very rewarding. But be careful with Python. So apparently, it's turning out to be the most popular language right now. Like it's kind of on a trajectory. I would have thought it was Kotlin, but so. Backend stack, you may be wondering, oh, what do you recommend? Like, what should you build your backend on? Here, I'll just say that as much as I would love to, like, say, use Kotlin for the backend and use gRPC or GraphQL and take in protobufs, just go with whatever stack you have in-house already. It's going to give you two things. First of all, hopefully your data or sort of your ops team can help you out and maintain your stuff. And second of all, maybe you'll get some contributions from your backend developers. So don't fight against the tide. Just go with whatever you have in-house. So now let's talk about the fun part, which is the actual developer experience of the system that we've built. Very quickly about trends. And you've already seen this screenshot a couple times, but I would like to highlight a couple things. So first of all, the x-axis here, you'll notice that it's the Jenkins build number, which seems like a very weird choice for using, on the x-axis. The issue here is that you need something that is monotonically increasing and that can be correlated back to the code changes in the order that they were merged. And PR numbers, unfortunately, are not good for that because somebody can open a PR but merge it out of order with another PR. So far, Jenkins build number is the only unique identifier that I found that was just monotonically increasing, so that's what we use for the x-axis. And you'll notice this little green circle here. I'm not sure it will be highly visible on the screen. What is that? Whenever you see changes in trends, you immediately start asking yourself what happened there. And so in this kind of area, we overlay the information about a performance alert that was sent there. And our goal is to eventually have an alert for every single change like that. If we fail to send an alert, we know we missed something. Now let's talk about the alert itself. So first of all, for those of you who don't know Slack, this is basically a Slack application. It's pretty easy to build. At the top here, you have some metadata that we can use, and show to the developer. Link to the PR number. One nice thing about the system is that since we run on every single merge to master, we can actually sort of like narrow down on the code changes pretty quickly, right? And PRs, looking at the PR often basically just uncovers what you did wrong. At the bottom, we have the section with metrics. Things got slower, things got faster. And here we have a link to more details because, well, we can't possibly fit everything into one Slack alert. And we have dashboard with a lot of details, but I'll highlight one that is particularly useful, I think, to determining whether this was a valid alert. Here we're showing you your current developer value in relation to the historical trend. And so you'll know that if it's outside the historical trend for, let's say, the last 100 builds, most likely this is a real alert. If it's not a real alert, it will look like something like this. Your current value is going to be within that sort of trend. At this point, you may be asking yourself, well, why don't you automate this? Why can't you use this as part of your algorithm to alert? And I'll say that is an excellent point. We should do that. It turns out to be not so easy because you're starting to deal with sort of like these rolling windows, and then how do you know when you should be resetting a window when things go up and down? And I'm sure it's doable. Maybe you can use machine learning for it. Since machine learning is usable for everything now. We definitely plan to do that in the future, but for now we just give it as sort of an indicator where a human can pretty easily right away determine whether this is real or not. And more info on debugging. It turns out that having these pre-merge alerts is really cool because you can actually run all sorts of experiments without having to merge them into master. So if you're working on a code path that you would like to speed up, you can add a metric to the system, open a PR, and run it and see if it does actually speed things up. This is great. Unfortunately, sometimes you don't have, when you get an alert, and especially if your PR is too big, which you should never do, but you still do sometimes, you will not know exactly, like let's say the search got slower, but you have no idea why your PR did that. And this is where detailed trace info would be absolutely amazing. If you could actually just look at sort of which methods got slower and faster immediately, it would be very nice. We don't currently have this, but we're looking into a tool by Facebook called Profilo. They actually use this tool both in their control testing environment as well as in production. And they sort of like gather samples of traces, and then they look at them, and they have a whole data pipeline that alerts their developers if something went wrong. So we are planning to also look into that. So finally, at the bottom here, you noticed maybe there's this little indicator that Adam indicated this was a valid detection and will fix this issue. Where does that come from? Well, in Slack applications, you can make them interactive, and we've been toying with this idea of, in general, in all of our alerts, including a micro-survey, where we ask the developer, is this a valid alert or is this noise? And what this will give us, if the developer chooses to answer the survey, is that we can actually start measuring trust. So here's an example of a dashboard, and I actually wanted to have a whole section on this, but I decided not to because of time. But our sort of key indicator there is the noise rate. We want to keep the noise rate under, let's say, like 0.5% over all the builds that we've tested. Okay, so we've come full circle in our diagram here. Hopefully now you know why you would want to build performance testing, other than your CEO yelling at you. And you know that it should be something for developers, not for some special team, in your company. And this took us about, I would say, 1.5 years of engineering work. It is not an easy project to take on. But I will say this, that if you plan to be around as a company for, I don't know, and then maybe the next 3 or 5 years, the time to start building these systems is now. We definitely missed sort of that sweet spot where we should have started building this way earlier. I wish that we had the system like already up and running 2 years ago. So definitely, take that and give it to your managers as, inspiration. At the end of the day, when I was starting, when I set out to build the system, I wanted to see developers start having conversations about the performance implications of their PR. I don't expect you to read this whole text here, just the first sentence. hey, y'all, Honey Badger is amazeballs. Oh, by the way, Honey Badger is the code name for our performance testing system. And then, they go and have a 51 reply Slack thread discussion about performance. So I would call this success. There's definitely still a lot of work to do. We're kind of just at the beginning, and we can do a lot of things that are better. But we've got a good start on it. And I hope that a lot of you will go back to your computers and maybe also start on the same system.